Excellent. So now that we have solved systems, and now that we've looked at linear equations, and we've even graphed linear inequalities, let's go ahead and look at a system of linear inequalities, which is made up of two or more linear inequalities. A solution is a system of linear inequalities, or an ordered pair that makes up all the inequalities in the system true. So the graph of the system of the linear inequalities is the set of points that represent all those solutions in the system. So this is an inequality that shows itself out in shading. And when you have an inequality system, it shows up in the shading, not where necessarily the lines overlap, but where the shading overlaps. So let's take a look at that. So for this first equation here, or for this first inequality, I'm going to look at the equation so I can get my line. So I've got my intercept at -3, and I've got my slope, rise 2, run 1, rise 2, run 1, run. Okay, and when I'm going to put my line, but I'm noticing that it is a less than sign, so I need to use a dotted line because the solution on this one is not on the line. It would be represented equal then. Okay, let's look at the second equation right here. I'm going to go ahead and move some things around so I can see it, and this allows me to see the y-intercept. It's at 2, and the slope is -2x. So rise, run, rise, run, rise, run. And this one is also, it's a greater than symbol, so this one will also be a dotted line, because the solution is not sitting, whoa, that is some dotted line, because the solution is not sitting on the line as represented with that symbol. Okay, we gotta find some shading here. Let's see what works. So my first equation, I'm going to plot a point. I like to use 0, 0 to see if this is true. All right, so I'm going to plug in 0, 0 to see if it works. So in this particular situation, I'll put in 0 equals, actually I need to go back to my original equation, or my original inequality. So 0 is less than 2 times 0 minus 3. So if this is true, that 2 minus 0 is 0, so -3. Is -3 greater than 0? -3 is not greater than 0, so 0, 0 is not a solution. So for this equation right here, the shading goes on the other side. The solutions are all played out here because, again, 0, 0 does not play out as one of the solutions. I'm going to do the same. This inequality, 2 times 0 plus, what number's back there? Oh, 0 is greater than 2. Let's see if that's a true statement. 2 times 0 is 0 plus 0 is 0. Is 0 greater than 2? That is not a true statement. So the solution 0, 0, 0, 0 is, that point is not a solution to this inequality. So because 0, 0 is right here, the solutions reside up here on this side. And I am looking for the overlap. And the overlap happens right in here. So this right here is the solution to my system. Now notice that because my line is dotted, it tells me that anything on this line is not part of the solution, anything on this line is not part of the solution, anything in this space is a solution. So a solution could be 1, 2, 3, 4, could be at the point 4, 1. A solution of 4, 1 does work in this system. All right, why don't you give it a try? Go ahead and plot these points, do some shading, find out where the overlap happens, try a point out to see if it is indeed true for the system. Pay attention to what line you're using. So how'd you do? This is what I found. So my first inequality, I played it out and found out that 0, 0 does not work. So I shaded away from 0, 0 on the other side of my line. And on the other one, I also tried 0, 0, and that also doesn't work, so I shaded on the other side. A couple other points of detail, and I noticed that it was greater than or equal to, so it's a solid line because my solution can reside on the line. Same with the second inequality. It is less than or equal to, so it tells me that it can reside on the line. So I'm using solid lines on this one, and I'm looking for their overlap. So the solution of this system of inequalities is in the highlighted area. You can combine your knowledge of linear equations with your knowledge of inequalities to describe a graph using a system of equations. So let's go ahead and take a look at this and see if we can find the two inequalities. So for this line right here, I can see that I can see my y-intercept, and I can go ahead and calculate my slope of 1 and 1. So I can use that information for y equals, just writing my equation, 1 over 1, so it's a positive slope of x, and the y-intercept is at -1. Now I can see that it is a solid line in this particular case, so I know that it's going to be equal to, so, which is true here, and I just need to determine if it is, let's look at if 0, 0 is a true statement on this one, or if it is not. So I'm going to plug in 0. So I'm going to try the equation of 0 being greater than or equal to x minus 1, and I'm going to try the point of 0, 0. Let's see if we can get this to fit. Okay, is 0 greater than or equal to -1? 0 is greater than -1, which is shading this way, and that is what we're looking for. So this indeed is my first equation. Let's look at the second equation, or inequality in this particular case. So I know that y, and I can see that my intercept is at, what, I didn't even count, 1, 2, 3, 4, 5. It's going to be at +5. I can see that the slope changes at 1, 1, 2, so it's a negative slope. It rises 1 and runs 2, so it's going to be -2x. I see that it's a dashed line, so it's just going to be greater than or equal to. I'm going to go less than -2x plus 5 and see if 0, 0 works on this case. So is 0 less than -2 times 0 plus 5? 0 is less than 5. Is 0 less than 5? Yes. So it is shading this direction, and we can indeed see the overlap is happening. So this indeed is my inequality, my equation of my inequality. So I found my two equations. Why don't you give it a try and give me a little bit of reasoning to back it up. What is your equations of your inequalities for this system? Okay, as I was working on my inequalities, again, I keep calling it building an equation of an equality. That's kind of a silly thing to do, a silly way to phrase it, but I start by building my equation, and then from there I can build my inequality, because my equation gets me my slope, my equation gets me my intercept, and my inequality will tell me what symbol I'm using, less than or greater than, and if it should be equal or not. Now notice if I'm shading down, I'm using less than. If I'm shading up, I'm using greater than. So for the red line, I tried less than. And it did work out in this one. And a detail is, notice that on right here I did use less than, not less than or equal to, because it is a dashed line. On the blue one here, when I played that one, it is below the arrow. So again, I did less than. It is a solid line, so I used less than or equal to symbol all the way through. And I gotta make sure I fit that in. And so there's my first equation, and here's my second. Inequality. So this is my system of inequalities. You can also model any real-world situations. These are the things you guys call word problems, but they're real application stuff. So let's look at time management. You're planning what to do after school. You can spend at most 6 hours daily playing basketball and doing your homework. You want to spend less than 2 hours playing basketball. You must spend at least 1.5 hours on homework. What's the graph showing how you can spend your time? So what do we know? We know that I have a highlighter. That's awesome. We know that at most 6 hours playing basketball and doing homework. We know that's at most. We know it needs to be less than 2 hours playing basketball. Okay? And we know at least 1.5 hours doing homework. What we need. We need to find different ways you can spend your time. Okay, that's what we're looking for. So what's our plan? Our plan is to write and graph an inequality for each restriction. Find the region where all three restrictions are met. Okay, so we're building our equations from it. So let's build our let statement. Let x be the number of hours playing basketball, because that's one piece of it, and y being the number of hours doing homework. These are two things that are varying. If we consider our system of inequalities, we can see at most 6 hours of basketball and homework. So it looks like this. So both of them together at most will be 6 hours. So it could equal 6 hours, but it needs to be less than. So my inequality, less than 2 hours of it needs to be basketball. So x needs to be less than 2, and at least it needs to be 1.5 hours of homework. So y, being homework, can be greater than or equal to, because you can do more, but at least it needs to be 1.5 hours. So we're looking at our three different inequalities. And here is where they're all playing out on a graph. All three of them, and we're looking where all three kind of meet each other. So we can see where x is less than 2, which is our vertical line, and it's dashed because it needs to be less than 2. We can see our other equation of y equals 1.5. That's a solid line because it can equal 1.5, but it is going to be greater than that, so that's why it is going up. X needs to be less than that, so that's why it's going to the left. And then we have x plus y is less than or equal to 6. So once that is graphed, we know that it moves down, and we see that all three overlap right in this region. So when we graph the system, because time cannot be negative, the graph makes sense only in the first quadrant. The solution of the system are all the positive points in the shaded region, including the points on the solid boundary line. So we're looking at our solution being right here, and the shaded part this way, and on here. All right, why don't you give it a try? You want to build a fence for a rectangular dog run. You want the run to be at least 10 feet wide. The run can be at most 50 feet long. You have 126 feet of fencing. What is the graph showing the possible dimensions of the dog run? So you have to consider your inequalities. Can it equal it? Does it need to be greater than? Build your inequalities first. When you're talking about a rectangular dog run, you are pretty much working with perimeter. You have your length and you have your width. And if you're talking perimeter of something, you know that there are 2 widths and 2 lengths. So we need to take that in consideration, and that's why in this inequality it's playing out right here. 2-year widths plus 2-year length needs to be less than or equal to 126. Because remember, we could make it less. It doesn't have to be that exact amount, but it can be less than. But we have up to that amount. We know that x needs to be less than or equal to 50, and we know y needs to be greater than or equal to 10. And so we play out our 3 different inequalities on here, and notice they're all equal then also. So thus all the solid lines, and the shading plays out. Less than 126, less than x, so this way. Less than, oh, actually that's going to be greater than right here, so that's why it's going up. And that's why they all collide right here, being the solution to my inequality system here. So anything in here will be a solution to this system. All right, speaking of inequalities, I'm going to go eat a Play-Doh sandwich.